Okay, so welcome everyone. My name is Mark, and just as you, I also studied UvA, and I just graduated from a bachelor, and I want to give you a session in Finance 1, and I will talk about discounting when you have annuities, perpetuities. We're going to talk about the internal rate of return and the effective annual rate. Those are the topics we will have today. It's something like 30 slides. Um, so I think it will last for something like 2 hours. Then we're done at 6 o'clock. And I want to say that you can just ask a lot of questions. So feel free to turn on your microphone if you have a question or something. I actually prefer that. You can also use the chat if you're a bit shy, but it's actually better if you just turn on your microphone because then you get a more natural interaction. I will also sometimes call your name and ask you a lot of questions. And I do that so that I can check if you really understand it. So feel free to answer my questions. So let's just start. So I will send this summary afterwards to you guys. The first thing will be really basic. So it might look a bit easy in the beginning, but I promise that it will get more difficult during this session. It starts with the net present value, and it's basically the present value of all the positive cash flows minus the present value of all the costs. And you can see the cost most of the time just as your investment that you have to make to get the positive cash flows. Okay, to give you an idea, I will give you a lot of whiteboard questions. So the whole idea of a present value is as follows.
Excuse me.
Yeah, of course.
Uh, do you recommend we take notes of the slides on the presentation?
Well, I wouldn't copy the slides, but you can copy the examples if you like. So I will make sure that you have some time for that. Yes, but I will also send you the slides afterwards, so you don't have to write everything down because you will get the slides. But
All right.
maybe some things I say that is not in the slide, then you can write it down if it's something that's not in the slide already. Um, yes. Okay. If you want, I can also send you the PowerPoint already, if you want that.
No, it's all right.
Would
Thank
that
you.
help? Okay,
No, it's okay.
great. So let's say there are two time periods. You have time 0, that's today, and T1, which is next year. And let's say that your interest rate is 10%. You can choose. You can choose between having 100 euro today or 120 euro in the future. What would you guys choose? 100 euro today or 120 euro in the future? Does anyone have an idea?
I'm assuming the 120 because it's worth more in the future.
Exactly. So the first thing you have to notice is that the cash flows are in a different time period, which means that we cannot compare them yet. The first thing you have to understand is that you have to convert the cash flow into the same period. One way to do that would be by using the future value. So we can say, all right, if I put this 100 euro on the bank, then I get 10% interest on it. That would only give me 110. And since this future value of this 110 is lower than this future value, this is the better option. Okay, that's one way to do it with the future value. You can also use the present value. With the present value, you don't convert this one into the future, but instead you convert this 120 into the present. So what you do is you do this one divided by 1 plus the interest rate. Could somebody plug that into his calculator? What would be the present value of this 120? What would we get?
109.1.
109.1. And then you say, all right, the present value of that 120 is bigger than the present value of this 100. Therefore, I choose the 120. That's the idea, that you can only compare cash flows if you denote them into the same time period. Thank you very much. So that's the whole idea of taking the present value. Okay. So sometimes you have to do an investment to get the present values. So let's say that it's something like this. Maybe I can already show you the example. You have to invest 100 euro to calculate, to get this 120 cash flow. So you now invest 100 euro and then you get this 120. That's a good return, right? You basically make a return of 20%. And if the interest rate is only 10%, we can now calculate the net present value. And the net present value is basically how much richer you got just because you made this investment. And we calculate it by taking the present value of all the positive things minus the present value of all the negative things. So this minus 100, it's already denoted in terms of today. So I don't have to divide by something. And since this 120 is 1 year into the future, I divide by 1.1. And now we want to calculate how much richer did we get by making this investment. And then we can calculate that. And what do you guys get? I think you said this one was 109.1, right? So then you should get 109.1 minus 100 should be 9.1, actually 9.09, right? Okay, so this is how much richer we got by making this investment. Okay, so if it's positive, you should do this project because it makes you richer. That's the basic idea of a net present value. Okay. Sometimes you can choose between multiple projects. In that case, you do every project with a positive net present value. You do all the projects that make you richer. You will not do any projects that have a negative net present value because that would make you poor. And sometimes a project can be mutually exclusive, and that means that you cannot do all the projects at the same time. You have to choose, you can only do one of the projects. Then you should go for the project with the highest net present value. And those are the decision rules. So basically you can summarize it like always maximize the net present value. That's the main idea of finance, that you want to maximize the net present value. Okay, so let's do some more complicated examples. You can also have 3 time periods. So then it works like this. You make an investment of 200, then you get 100 euro next year, 100 euro in the year after that, and 100 euro in the year after that. And if I make this investment, how much richer do I get or how much poorer do I get, depending on if the NPV is positive or negative. So I start by writing down NPV is minus 200 plus this 100, but this 100 has to be converted 1 year back into the present. So I divide it by 1 plus r only one time. However, this 100 that we get 2 years from now, I have to bring that back 2 years back into the present. So this one will be divided by 1.1 with the power of 2. And this third one will be 100 divided by 1.1 with the power of 3. Okay, could somebody calculate this for me? What do we get? And I will also calculate with you.
I got 48.6.
48. Could you give it to me with 2 decimals?
1 second. I only calculated in 1 decimal place.
Oh, okay. I think you get 6.9 then. Is that correct?
Yeah, that's correct.
Very good. So that's how you calculate a net present value if you have multiple periods. You just use the power of the time from the question. So if if it's 3 years from now, you do with the power of 3. And it always helps if you get like a question to first translate the question into this table that you're seeing here. That really helps you a lot. Then you get a better overview of what you have here. Okay. So I think that's the basic idea of taking the present value. However, you sometimes might have that you have an annuity or perpetuity, and then you can have it with growth or without growth. So I don't know if you ever had a look at your formula sheet. Then you see those formulas here, and I'm going to explain when to use them, but also how to make corrections on them, because sometimes they don't literally ask you for the formula, but also you have to make some corrections on it. And that's what we're going to practice today. That will be the main topic. Okay, what is an annuity? An annuity means that you get a fixed cash flow each year for a finite period. So for example, you get 100 euro next year, 100 euro 2 years from now, 100 euro 3 years from now, all the way up to, for example, 30 years from now. And you can imagine that it would take a long time to discount that if you do it in the method we just discussed. So then you would literally get 30 fractions if you get 30 different cash flows each year. So therefore, you would like to use a formula like that because it would take too much time to plug it all into your calculator. That's what we're going to discuss. So the examples I use are also basically in the summary. So let's say that we have T0, T1, T2, T3. And each year you get 100 euro. And let's say the interest rate is 10%. Well, we first say method 1 is that you do 100 divided by 1.1 plus 100 divided by 1.1 squared plus 100 divided by 1.1 cubed. And then you get a particular number. I don't know if we already calculate this. I don't think so. So maybe we can calculate it really quick. I got 248.69. Do you guys also get that? That's the old method, right?
Yeah.
But you can imagine, now I got the fixed cash flow for 3 years in a row. But what if you would get it for 30 years in a row? Then you would have to write down 30 different fractions, and you have to plug it all into your calculator. So that would take a lot of time. So therefore, we have a particular formula, and that's this formula here. Let me see if I can erase it. Here you go. If you have an annuity without growth, there was no growth, it's just 100 euro each year, then you can fill in 100 euro here for the C. And then you write down here your discount rate. And for N, you write down how many cash flows you got. So you got 3 cash flows. So for N, you can fill in 3. And if we do that, so now you might, I think actually it's, on hindsight, it might be better if I show you the summary. So I will share the summary with you, then you don't, and then in between you can just copy the formulas. But maybe it's helpful if you want to check the summary. So I will do that really quick. Okay, so I now will send it via WhatsApp to you guys. Okay, so there you go. It's now in the WhatsApp. So if you look at the, welcome Philip. So if you look at the formula sheet, you start by writing down the C, and the C is 100 in our case. Then you do times 1 divided by R, which is 0.1. So not 1 plus R, but R. And then 1 minus 1 divided by 1 plus R, which is 1.1. With the power of N. And with N, we mean how many times did you get a cash flow? And we got 3 cash flows here. Okay. Could you guys plug this into your calculator? So this is the second method to get this. See it for yourself. See what you get. So welcome, Philip. For now, I will mute you just to be sure. But if you have a question, you can just unmute yourself. I actually prefer that. So. Okay. So what do you guys get here?
The same answer as the first one.
Exactly. So this formula here below is just normally a quick way of writing down this whole series. So they're literally the same. So this here is the same as this complicated formula, but it's just a quick way to write it down. For example, if you would get 30 times 100 euro each year, then you can simply change this into a 30. While if you do it with the first method, you have to write down 30 different fractions. So that would take you a long time to calculate. Therefore, we need this formula. So this is annuity. You get a fixed cash flow each year for finite period. Okay. Then the second example. And by the way, if I go too fast, just slow me down. You can just ask, whoa, can you wait 1 second? Then I can copy this. You can just ask me that. Okay. Second situation. We get 100 euro at year 1, 110 euro in year 2, 121 in year 3. And then I hope you already see it. The G is 10%. So we now have a growth rate. And then I get 3.1, 133.1 in year 4. And those are my cash flows. And the discount rate will now be 20%. So here you have a annuity because it's a finite period that we get those cash flows, but now there's a growth rate in it of 10%. And then there are again 2 ways to calculate the present value. One way is to say 100 divided by 1.2 plus 110 divided by 1.2 squared plus 121 divided by 1.2 cubed and 131.1 divided by 1.2 to the 4th. Okay. However, you can imagine that again, if you have 30 different cash flows, that it would take you a long time to calculate the present value using the first method. So what you would like to do instead is you would like to use a formula, and that's the formula you're seeing here, to calculate it way faster. And this formula is also in your formula sheet. So you can just fill it in. You say, all right, the C is the cash flow from your first time period. So if you want to know the C, what do we have to fill in here for the C? You fill in what you have in the first time period, which is 100 in our case. Then you do divided by R minus G. The R is 0.2 and the G is 0.1. Then you do 1 minus, and then you do a fraction with 1 plus G divided by 1 plus R with the power of N. For the G, we fill in 10%, so we get 1.1 in the numerator. For the R, we fill in 20%, so we get 1.2 in the denominator. And what again do you think we have to fill in for the N?
Four?
Yes, 4. And that's the amount of cash flows you have. You get your last cash flows 4 years from now. So we fill in a 4. And could somebody fill this into his calculator? What do you get? What do you guys get?
Is it 293.93?
Yes, I also get that. So there are 2 different ways to calculate the present value. And the second formula you will need when you have a lot of cash flow. So here for 4, yeah, then it's actually easier to use the first method. But like I said, if you have like 30 different years, then you're forced to use the second cash flow. It would be too much work to do it into your calculator. Okay. Is this clear so far? Or are there any questions? Okay. So with those 2 formulas, we assume that we had a finite period. So only 30 years or 40 years. But you can also have a perpetuity. A perpetuity is basically the same as an annuity, but now you have an infinite duration. So you will get an excellent question like, assume you live forever and you get 100 euro each year. Then you get literally an infinite amount of 100 euros each year. 100 euro next year, 100 euro in the year after that, etc., etc. In that case, you really need this formula here. And then again, you have 2 options. You can have it with growth. Then you have to plug a minus G into the denominator, or without growth. So let's have a look. 0, 1, 2, 3, all the way up to infinity. So you get 100 euro next year, 100 euro in the year after that, 100 euro in the 3rd year. So you get infinitely many 100 euros. And let's also assume that the R is equal to 10%. Okay. So what would be the present value here? If I would use the first method, I would have to do 100 euro divided by 1.1, 100 euro divided by 1.1 squared, 100 euro divided by 1.1 cubed. But yeah, I could go on and on forever. So this is not possible anymore. Fortunately, we have this second formula, which is C divided by R. That's what you can use when you have this situation. No growth and an infinite duration. So what you do P V C divided by R, which is 100 divided by 0.1. And what would you get? I don't think you even need a calculator.
1,000.
1,000. Very good. Thank you, Ami. So that's what you get here. And what's the intuition here? Well, if you have 1,000 euro, you put it on the bank, then each year you would get 100 euro of interest that you get. And if you don't touch the principal, the 1,000, and only use the interest, you can pay yourself 100 euro each year. That's the intuition here. So getting 100 euro each year is the same as having 1,000 euro today, because that 1,000 would pay you those cash flows as interest. And therefore, that's the present value. Does that make sense? Okay.
No, 1 second. So can't you just say that you get 1,000 in like 11 or 12 years anyway? I don't know how
Sorry,
long.
could you repeat your question? Oh,
I don't understand how you can say it's 1,000 when you're going to earn 1,000 in a particular span of time anyway.
so
Basically,
the idea,
I don't understand the
if you have
iterations. Yeah.
okay, so if you have now 1,000 euro today, then next year it would become 1,100 euro, right? And then you could pay yourself this 100 euro and still have 1,000 euro left. Then in year 2, you would again have 1,100 euro, and then you can pay yourself 100 euro and keep the 1,000 for next year. The next year it would be 1,100 euro again, which means you can pay yourself 100 euro cash flow and keep the 1,000 euro as a principal for next year. So if you now have 1,000 euro, you literally could get 100 euro each year, like I say here. So getting 100 euro each year is the same as having 1,000 euro today. And I think maybe the answer to your question is that the key idea is that 100 euro today is not the same as 100 euro next year. We said in the first example that I could only compare cash flows if they're in the same time period, right? So having 1,000 euro today is worth more than 1,000 euro next year. That's the idea. I think that's the answer to your question. Does that answer your question?
Yeah. So basically, when it reaches a certain point, you can just keep taking out 100 euros and then have the same thing again and again. Have the same 100 euros every year.
Yeah, so if you have this 1,000 euro, you can pay yourself 100 euro every year. Therefore, all those 100 euros are the same as 1,000 euro today.
Yeah, got it. Okay, thank you.
So that's a bit strange, right? You would think, well, how much is this worth? Well, infinite. You get infinite many 100s. But then that's not true, because you have to take into account the time value of money. 100 euro today is worth more than 100 euro next year. Basically, if you get 100 euro in 1,000 years, it's worthless. That's the idea. Okay. Okay, so now the question is, what if you have growth? Then you have to use this formula here. So let's say that it goes as follows. If t is 0, 1, 2, 3, all the way up to infinity. You start with 100 euro, then 110, then 121, then 133.1, and then it increases with 10% each year, all the way up to infinity. So here the growth rate is 10%. Let's say the discount rate is 20%. Well, again here, with method 1, the present value would be 100 divided by 1.2 plus 110 divided by 1.2 squared plus 121 divided by 1.2 cubed. And you would literally get infinitely many fractions. So this is not doable in the exam. So because of that, we need to have a particular formula. And that is the C divided by R minus G. So my first problem is, what do I again have to fill in for the C? Because there are different cash flows each year. Do you guys remember what I had to fill in for the C?
It's always 100.
Yes, always this 100. And then R minus G, so 0.2 minus 0.1. And then I also get 1000 here. That's the ID here, that you basically this whole series that is infinitely long is also worth 1000 euro. That's the ID. Okay. So is it clear when to use which particular formula? Is that clear for you guys? Because that's the easy part, recognizing when to use which. You look at two things. You look at, is it an annuity or perpetuity? So is it a finite period or an infinite period? And a second question, is it with growth or without growth? So you get 4 different situations that you have to know. Okay, if that's clear, I'm going to make it a bit more difficult. I'm going to make some complications. And by the way, if you want to have a look at the summary, so how I brought it up is you have the formulas that you need to know. And then I inserted some examples that we already also discussed on the whiteboard. So you can just look it back. Annuity without growth, annuity with growth, perpetuity without growth, perpetuity with growth. So you also have some nice examples in the summary you can read. But now I'm going to discuss some complications with you guys. The idea is as follows. You want to calculate the net present value here. And you have to make an investment of 200. Then you basically receive 100 euro each year, 100 euro each year, except in year 2. There you receive 40 euro extra. And that's a problem because the formula assumes that you get 100 euro each year and not 140. So the question is, how do you correct for this? You basically treat it like you would normally do. So maybe I can ask one of you guys. Lily, are you there?
Yes.
Oh, you're there?
Yeah.
Which formula would I normally fill in? So I write down minus 200 to discount this for this investment, basically. But how would I normally calculate the present value of this 100, 100, 100, 100, 100? How would I normally do that?
Just like in the first year, we should be 100 over 1 plus 0.01 and plus
Yeah, very good.
yeah, and plus 140 over 1.
Yeah, you're now basically writing down this here, right?
Yeah.
Yeah, but we had a second method, and we said we have to use the second method. For example, when you have a lot of cash flow. So now I did it with only 5. Okay, then you can just use this method you're saying. But I want to do the second method because you need that for the exam when you have multiple periods. If you, for example, have 30 or 40 periods, then this first method would not be feasible anymore. Okay, so how would you do it according to the formula we just discussed? So my question is, how would you discount all the 100 euros if you would get 100, 100, 100? How would you normally do that? Maybe somebody can help her? So
just be you do 1 minus 1 over 1 plus r normally when
yes,
it 140 was 100.
exactly. And with the power of what?
That would be 5.
Yes. Very good, Is your real name, by the way, or is it or did you shorten it?
It's shortened, yeah. It's my full
Oh,
name is
what's your real
Omkar.
name?
My full name
Sorry?
is Omkar. Omkar.
Oh, okay. Omkar. Okay. Um, but this is correct. This is if you would get this part, if you would get 100, 100, 100, 100, right? That's what this formula represents. However, you didn't get 100 euro here. You got 40 euro extra. So because of that, we have to make a correction. So what we do as the correction is we add 40 euro here. But notice that this 40 euro extra is in year 2. So it has to be discounted like this, divide by 1.1 with the power of 2. Does this correction make sense? This 200 is just this 200. But all those 100s here, that's basically this thing here. If you discount it. And in year 2, you got 40 euro extra, and therefore we made this correction of 40 euro. Okay. Could somebody insert this into his calculator? See if I did it correctly. We'll also do it with you. Minus 200 plus 100 divided by 0.1 times 1 minus 1 divided by 1.1 with the power of 5. And what do you guys get?
212.14.
Perfect. That's also what I got. Thank you, Ami. Okay. So this was if you get 40 euro extra. What if you got something less? Let's do that on the whiteboard. Luca, would you like to help me with the next example? What if you would get it like this? 0, 1, 2, 3, 4, 5, 6. Each year you get 200 euro. The interest rate is 15%. But in year 3, you only get 175 euro. Luca, are you there? No. Then I will ask Philip. Oh, you're there. Could you turn on your microphone?
Yeah, of course.
All right, thank you. So how would you calculate the present value here if you had to use the formula with the correction? What would you do if you had 200 euro each year? what would you then do?
So constantly getting 200 euros.
Yeah, so one way to do this is 200 divided by 1.15 plus 200 divided by 1.50 square. But that would
Yeah.
take too much time. I'm too lazy for that. So I want to use the formula.
The formula for the annuity.
Yes. Let me show it you one more time. That was the formula here below, right?
Yeah.
Okay. So 200 times then, what do we have to do?
1 over 0.15.
Yes, perfect.
Times
Times
1 minus 1 divided by 0.15.
1.15, but no, not
Oh,
the problem.
1.15.
And what should I put in the power here?
6.
Is 6. And this is if I would get 200 euro each year. So very good. The problem is I didn't get 200 euro in year 3. I only got 175. So how should I correct for that? Do you have an idea? So when I got 40 euro extra, I would add 40 euro. But now I got 25 less. So what do you think I should do?
No clue.
Could somebody help him? Maybe somebody knows.
Is it minus 25 divided by 1.15 to the power of 3?
Perfect. You got 25 less. So you need to correct for that by subtracting 25. And you do divided by 1.15 with the power of 3 since it's in year 3. Does it make sense, Luca? And then you can, again, plug this into your calculator and you can see what you get. Let's do it. That would be nice. Maybe 200 divided by 0.15 times 1 minus 1 divided by 1.15 with the power of 6 minus 25 divided by 1.15 with the power of 3. What do you guys get if you fill this in?
740.46.
So what did you say, Philip?
740.46.
Sorry, I don't hear you. How many hundreds? What, 200?
740.46.
Yeah. Yes, I also get that. Very good, Philip. And you round it to a 6 indeed. Okay. Very good. Is this clear for you guys? How to make corrections if you have a one-time extra cash flow or a one-time lower cash flow? Or I could also change it, right? Maybe, what do you think, Luca? If I would make this into a 210, what would you then also do as an extra correction? If this would be a 210 instead of a 200. What would you do, Luca? Then you would add 10 divided by 1.15 to the power 5, right? To correct for that. That's the whole idea, that you have to see that here. Okay. Does this make sense? Okay. Then we go to complication 2. Complication 2 that you can encounter on the exam is that you have a delayed cash flow. So let me show you what I mean with that. I will do it on the whiteboard. So notice that in all the previous examples we did, we assumed that the first cash flow was in year one. So the formula naturally assumes that your first cash flow is in year one. That's the cash flow you always use. However, it could also be the case that the problem looks like this. 100, 100, 100, 100. In this case, let's, by the way, keep it a bit more simple. Let's also ignore the 6. Let's say that the R is 10%, and we want to discount it. Here, the easy method would be to say, all right, present value is 100 divided by 1.1 to the power of 3 plus 100 divided by 1.1 to the power of 4 and 100 divided by 1.1 to the power of 5. Okay, everybody knows that, right? That's easy. The problem is that sometimes they will not do it for only 3 times, but maybe for 30 times. So then it would be a lot of work to write this all out. So we need to come up with some formula. But the problem is that our formula we use so far only works when your first cash flow is in year 1. But here we don't have that. Here your first cash flow is in year 3. So what you do is you basically assume for a second that it already starts in year 1, 2, and 3. And then I'm going to ask Eva, how would you calculate the present value of those blue cash flows? With the formula.
Yeah, would you use like the normal formula and then subtract like the first 2 years from it?
Like this?
Yeah.
Yes. And my question is, how would you normally, what would you normally put into your power? If you would have it like
3 years?
Yes.
At 3.
At 3. Okay, very good. But the problem is that now you're assuming that your first cash flow is in year 1 instead of year 3. You're assuming that your second cash flow is in year 2 instead of year 4. You're assuming that your third cash flow is in year 3 instead of year 5. So the problem is that you should actually discount everything 2 years extra. And the 2 is the difference between this 3 and this 1. So the formula is used for year 1, but now the first cash flow is in year 3. So you should discount it 3 minus 1 times extra. And that's what we're going to do here. So our correction will be that I divided by 1.1 with the power of 2. That's to correct for that. Do you guys understand this? That I have to make this correction? And why this 2? Because I have to bring everything 2 years back into the present to be able to use the formula. And you don't have to believe me that this correction works. So maybe half of the class can fill in this first formula, this first method, which is the easy method, right? If you have only 3 cash flows, that's the way I should do it. But you also need to be able to do it with the second method on your exam. And let's check if you get the same outcome with both the 2 methods. So maybe half of the class can use the first formula and the other half can use the second formula. And see if you get the same answer, because you don't have to believe me without checking. What do you guys get?
$205.52.
Yes, 205.52 with both methods. And that's how you can do a correction when you have a delayed cash flow. So here the delay was 2 years, therefore you're putting a 2 here. Okay, very good, Ava. Okay. Philip, would you like to help me with my next example? 0, 1, 2, 3, 4, 5, 6. All the way to infinity. So you get 150 euro each year. And your first cash flow is 4 years from now. How would you, and let's say that the R is 10%. How would you discount this?
We use the formula for perpetuity without growth rate. And
Yes, very good.
divide
So
by
it's 150 divided by 0.1. But that's assuming that your first cash flow would be in year 1, right? But that's not the case. Your first cash flow is in year 4.
Yeah.
So what should you do?
So we'll multiply that by 1 minus. I said multiply.
Sorry, with the power up?
I said we'll multiply 150 divided by 0.1 by 1 minus. If I'm right.
4 minus 1, right? So the 3. So each cash flow has to be discounted 1. Oh, sorry, 1, 2, 3 extra times. You see that? 1, 2, 3 extra times. Therefore, I put a 3 here. What do you get?
1,126.
Yes. Very good. Like this, right? Is it what you got?
Yeah.
All right. Thank you, Philip. Is this clear for you guys? Is it really clear, or do I need to show an extra example?
So I just
Do you
wanted
guys?
to be clear. The last example we had, we multiplied, like, we also added 1 minus 1 divided by 1.1 raised to the
Yeah.
power 3.
So here we had the 1 minus. So your question is, why do we use the 1 minus here and not in this case? Is that your question?
Yeah.
That's because it's a different formula. So you have a finite time period, an annuity, then you have to use the 1 minus, because here we only had it for 5 until time period 5. But here you go all the way up to infinity, and then you have a perpetuity, which has a different formula. You see that?
Yeah.
So it's the difference between this formula below, which is an annuity, where you have to do 1 minus. And the perpetuity, where you don't have to do that. Do you see the difference?
Yeah.
Okay. Were there any other questions? Okay, let's do an axiom question. So everything I'm telling you, you can look it up back into the summary. So what I said here is I showed you that you didn't get any cash flow in year 1 and 2. So the delay is 2 years, 3 minus 1. And therefore you put a 3 here because you have 3 cash flows, not 5, but you only have 3 cash flows. And since you have a delay of 2 years, 1, 2, you have to discount it by 1.1 with the power of 2. So everybody understands this correction in the summary? What you have to do if your delay is 2 years? Okay. So here are some axiom questions. And after those axiom questions, we have a small break. Okay. So just take your time and you can say in the Zoom chat your answer. And do it with a private message so that not everybody can see your answer. Else you are going to spoil it. And you will see that it is a bit difficult maybe, but and it might help to first make a table. So after this question, we have a small break. And my question is, how many payments do we still have to make? Is it 20, 12, or 8?
It's 8, right?
It's 8 payments. We originally had to make 20 payments, but we already lived in the house for 12 years. And we just made our payments, so we did 12 payments. So we only have 8 left. The first payment, will that be today or next year? And remember, we have just made a payment. So we have to, do we have to make another payment today, or will the next payment be next year?
Next year, because you've just made a payment today. So yeah, next year.
Okay. So I'm waiting for the answers. If you have it, you can send it to me in a private message. By the way, there are, I think there are 30 slides or something. So just so that you have an idea how much we have to discuss. Okay, I see the first answers coming in. Okay. Did everybody submit his answer? So you can send your answer with a private message. So I will just call you OM. OM, would you like to help me with the solution? I think he's not here. Oh, there you are.
Yeah, no, yeah. So I assume that you'd first have to find out the present value of the 12 years. So that would be 10,000
Yes.
times 1 over 0.5, 1.05.
Yes. No 0.05, right?
Yeah, 0.05, sorry. And then
Times.
obviously 1 minus 1 over 1.05 to the power of 12.
To the power of what?
12. I did 12.
But you said that you had to only make 8 interest payments, right?
Oh, yes. I didn't get this right. That's why I wasn't able to find the answer. So.
Okay. Yeah, so we just want to find the present value of all those cash flows, right? That's what I still have to pay. So basically today is year 12, and this 8 is basically year 20. That's where we are today. Do you understand the story?
Yeah, I made a big mistake at the start. Yes.
No problem. That's basically their goal, to confuse you with the story, right? So don't worry, we are now in year 12, which is basically our 0, and year 20 is basically our 8 here. So that's how it works. Okay. But what would you get if you fill this in?
64,632.
Yes, 64,632. Thank you, Frida. Okay. And everybody that submitted his answer had it correct. So very good, guys. Okay.
Well, I have a question.
Okay.
Can we do it this way? For example, first calculating the present value of 12 years, and then the present value of 20 years, and subtracting it.
Let me think. Why wouldn't that work? Because then, so let me explain why that wouldn't work. It is again because of the time value. The problem is that we now are in year 12. That's our new time 0. And what you are saying, what you're suggesting, then you are still back in year 0. So originally there was a different 0, right? Then you would get a value that exists in that period. But we want to have the value denoted in year 12. That should be our new 0. And you wouldn't take that into account in the way you are proposing. That's what would go wrong in your answer. So if you would take all the cash flows from year 1 to year 20, minus all the cash flows from year 1 to 12, then you also get 8 different cash flows, but then they would be denoted in a different time zone than where we want to have it. You could do it, but then you also need to do times 1.05 with the power of 12 to bring it to the 12 years into the future. Because we already are 12 years into the future, and what you're proposing, then you're not 12 years into the future. That's what would go wrong then. Do you understand that?
Yeah, okay.
So you could do it, what you say, but then you have to do times 1.05 with the power of 12. Then you would get the same answer. But that would be way too difficult, actually. So
Thank you.
you're welcome. So here's the solution. It's just simply filling in the formula. But obviously the tricky part was that you had to see that you had to do an 8 there, and not something else, not the 20 or the 12. Okay, last question, and then we have a break. And then after the break, we're going to talk about the internal rate of return. And if we have some time, we will also do the effective annual rate. Okay. So again, try to first make a sketch of all the cash flows, right? So try to make this nice table. When will you get the first 20,000? At moment 0 or at moment 1? When do you get your first 20,000? At moment 0 or moment 1? That's my
Moment
question.
1.
Sorry?
Moment 1.
At moment 1, normally, right? With the formula, you normally get it at moment 1. But is it also the case if you read the question?
Oh, yeah, the first payment is today, so it's at moment 0.
Yes. And that means we have to make a correction for that, right? Because normally the formula assumes that the first payment is next year. but now we have it already today. And there are two ways to make a correction for that. So let's see what you guys coming up with. So again, I will say send the answer to me in a private Zoom chat. Send your answer. I got the first answer already. Oh, now I accidentally sent it to you. Sorry, Amy. So. Right. Amy and OM have the same answer. This is interesting. I get different questions, different answers from everybody. I can look really quick what the correct answer is. Yes, OM, you corrected yourself, indeed. And Philip, you also corrected yourself. But no, I don't think you still have it correct, Philip. Shall we do it together, Amy?
Sure.
Okay, what did you do?
So it says live forever. So the
Mhm.
first step is to divide 20,000 by 0.07.
Yes, very good. Then you have discounted this part of the cash flows, right?
Yeah.
Yes. And then?
And then I subtracted 20,000 from the amount that I got.
You subtracted
20,000.
or you added it?
Subtract.
But you get something extra, right? You get also at 20,000 at times 0.
Oh, yeah, add.
So you add this 20,000 here.
Mm-hmm.
Do you need to discount that, or is it already denoted in terms of today?
I'm not too sure.
But that's the resting. Do we need to discount this 20,000, or is it already in terms of today?
I thought 20,000 was the present value.
I
The present
discounted
value
it.
of this one,
I
you
discounted
don't have
it
to
and it was
discount
the
this
same.
one.
You don't have to discount.
So this is it basically. This 20,000, you don't need to discount it because it's already in year 0 basically.
Mm,
So do you guys understand this way of doing it?
so the answer is A.
Do you get, if you fill this into your calculator, do you get 305,000?
So I did 20,000 divided by 0.07, and that's where I got B, and then I multiplied it by 1.07, and that's when I got A.
Yes, that's the second way to do it. So I said you can basically see it like complication 1 here. Complication 1 was that you had a one-time extra cash flow. That's what I now proposed. But what you're saying is you're treating it like a delayed cash flow, but then actually the opposite, right? I will also show you that way. That's a good point. Okay. So here we treat this 20,000 here as an extra cash flow by simply adding it, and we didn't have to do divide by 1 point something because it's already in terms of today. So did you guys fill this into your calculator, and did you guys get this here? Is that correct, Amy?
Yes.
Okay. And then what OM did, he says, well, how I did it, OM says, is I treated it like the delayed cash flow. So for example, we first treat it like the first cash flow is at moment 1. So we treat it like, so this is option 1. Option 2 is you treat it like your first cash flow is at moment 1. Then you would discount it like this. But for example, if your actual first cash flow would be in year 3, you would also do times 1 divided by 1.07 with the power of 2, right? If your first cash flow would be in 3 instead of 1. Because you do the actual year minus 1 always, right? That's how it worked in the previous example. The actual year minus 1 to get this 2, for example. Here, the actual year is 0. So you do 0 minus 1 like this. And that also would give you 305,714.29. Do you guys understand that method also? So remember, this power is the delayed cash flow. The actual year, for example, 3 minus 1. If it's delayed by 2 years, you fill in a 2 here. But now it's actually delayed minus 1 year because you got it 1 year earlier. So then you can fill in a minus, and mathematically that's the same as multiplying it by 1.7. That's what OM did. Okay. Can I help someone before we have a break? Are there any questions or something? No? Is it clear for you guys? Because I cannot look at your faces to see if it's clear.
Clear for me.
It's
For you,
clear
it's
for
clear?
now.
Okay. Great. Shall we have a break then? Or would you like to have a break for 5 minutes or something just to go to the bathroom? Now we continue at 17.28. Okay. See you then, guys. Okay. So in 1 minute we continue. Do you guys, by the way, like this course? Or do you think it's a bit difficult?
In comparison to EMO, I think it's easier.
Easier, right? Yes. I think emo is also quite difficult.
Yeah,
Would
EMO
you
is
actually
very
also
difficult.
sure?
EMO
Yeah.
is very difficult.
But you still have to do that exam, right? Or you talk about your midterm exam, of course.
Sorry, what?
Which you also you had a midterm for emo that you found difficult. Oh no,
Yeah,
you had
the course
emo
in general.
along with macroeconomics, right? Yeah. I was confused in which period you have it. You already did the emo course, right? And that was really difficult. Yes. Because it was in period 4, right? The emo course.
I don't know if it's the
No,
same
no,
for
no, no, sorry.
everybody, but
No, I'm confused. So you have financial accounting and macroeconomics in period 4, and now you have emo and finance, right?
yeah.
Yes. And did you already have a midterm for emo? That was my question.
Yeah, it was last week actually.
Yeah, and you found
With
that
the
one
same
difficult, right?
with the same as finance. Finance is
Okay.
midterm.
Yes. And also math is quite difficult, or not?
Mathematics?
Math, yes.
Mathematics one was, I liked it. Personally, I liked
Oh, you
it.
liked it. Oh, that's good.
Yeah.
That's good. All right, let's continue then. Thank you, Amy. So here you have the internal rate of return. And what it basically tells you is it's the interest rate or the discount rate that would set the net present equal to 0. So the internal rate of return is the interest rate that would set the net present value equal to 0. And the general formula is 0 is equal to cash flow 0, then the cash flow from year 1 discounted by the IRR. So this thing that you normally use for the net present value should get a 0 as the outcome. So let me give you an example. Okay. So here you have a really easy example. How I always see it is you can basically have 2 situations on your exam. You can have that you only have 2 cash flows. So one cash flow in year 0 and one cash flow in year 1, or maybe later than year 1. Or you can have multiple cash flows. So here we only have one cash flow in the future, or you can have multiple future cash flows. If you have only one cash flow into the future, so like here, then it's actually quite easy. You write down your net present value formula. So you write down -1 plus 120 divided by 1 plus IRR. So this is what your net present value formula would look like. And you set it equal to 0. That's how you find the IRR. You set the net present value formula equal to 0. And then we need to solve it for IRR. So Eva, would you like to help me with that? Do I pronounce your name, by the way, correct?
Yes, you did.
Great. So how would you solve this for IRR?
Well, for example, move that 100 to the other side, and then
Yes.
Divide by 120, and then
Yes.
yeah, -1.
And then you get 20%, right?
Yeah.
So what is the IRR? It basically tells you what the return on your investment is. You're basically investing 100 euro here, and then you get 120 euro in return. So you made a return of 20% on your investment. Do you see that? That's what the IRR tells you, the return on your investment. It should be noted that the IRR is something different than your R. For example, if the R is only 10%, so that's the discount rate, would the NPV be positive or negative here? So again, the IRR is the interest rate that would be that would put the net present value equal to 0. So let me clear some things up. If I have an R that is smaller than 20%, for example, 10%, would the NPV be positive or negative in this case? So I'm dividing by a small number. Would you get a big outcome or small outcome? What do you guys think? So I don't want you to calculate it. I want you to tell if it's positive, 0, or negative.
Positive.
Yes.
Good.
If the R would be 20%, I would get 0. But if the R is smaller than that, I get a positive outcome, right? What if the R is 30%? Then I'm dividing by a really big number. So then this outcome is really small. And then because of this minus 100, the NPV would be negative. So at an R of 20%, the NPV is 0. If the R is smaller than 20%, the NPV would be negative. So I shouldn't do the investment. But if the R is bigger than the 20%, sorry, did I say it correct? Sorry, let me say it again. You probably understand me, but I want to be really precise in saying it. If the R is smaller than 20%, then the NPV would become positive, and then you should do the project. But if the R is bigger than the IRR, then you would get a negative NPV, and then you shouldn't do the project. Okay. Okay, so this is the case when you have only one cash flow into the future. So let's do another example. 0, 1, 2, 3. So you now invest 100 euro, and then let's say 4 years from now, you will earn 200 euro. OM, how would you find this IRR?
You have to equate it to 0, I'm assuming again.
So 0 minus 100,
Yeah.
plus 200 divided by?
Just 1 plus IRR.
With the power of?
4 to the power 4.
Yes, that's the difference here, right? And so what I said is, if you only have one future cash flow, the 200 here, then you can just simply solve it for IRR. How would you do that?
You take 100 to the other side, and then you switch around 1 plus
Yes.
RRR to the power of 4.
Like this, right?
Yeah.
And then you get
Fourth root of 2.
like this, right? What would you get?
1.8%. Sorry, 18%. 18.9%. Yeah.
Something like that. I could check.
Yeah.
Yes, it's 18.9%. So basically, what happens here is you invest 100 euro. Let's say that you make an investment. Then you put it on the bank, for example, for an 18.9% yearly interest rate. Then after 4 years, you would earn 200 euro, right? If you get 18.9% per year, that's basically what the IRR means in this case. You see that? That's pretty interesting, right? And remember, if the IRR is if the discount rate is smaller than the IRR in this case, then the NPV would be positive. Okay, that's what you need to see here. Then it's a good investment in this case. Here in the summary, you see a situation where you have multiple future cash flows. You have 2 future cash flows in this case. Here, it's really difficult to solve it. You could do it, then you need to do the ABC formula. I can explain it if you want. But here, because your action will be multiple choice, it is easier to use trial and error. So what you will do is you will translate this question into the setup of the formula. So 0 is minus 200 plus those things. And then you simply try out the different answers. And the answer that gives you the answer that gives you an outcome closest to 0, that's the correct answer. So for example, if I first try this 5%, I fill in the 5% here. Do you think you get a really big NPV or really small NPV in this case? If I would try out this 5%, I insert it. Do you think I get a big NPV or small NPV?
I think a big NPV.
Get a really big NPV, right? So here, if I try 5%, I get, I don't know what the number is, but it's way bigger than 0. Then I try out this 10%. So I try it out, I fill it in into this formula, I put it into my calculator. And then I see, hey, this one gave me an NPV bigger than 0. Now I've tried the NPV of 10%, and that gives me an NPV exactly equal to 0. And then I know, all right, answer B is the correct option. Do you guys understand that? If I would, for example, try the 15%, then the NPV would be smaller than 0. Would I try the 20%? Then it would be even smaller than the previous answer. And that's the whole thing here. So do you guys understand that? You just simply try out the different answers, and then the answer that gives you an NPV of 0, that's the correct answer. So that's B in this case. Okay. In theory, you could also use the ABC method to do it. Then you say, all right, X is 1 divided by 1 plus IRR. And then this equation becomes minus 2 then it becomes 121x squared, which is this fraction, right? Plus 110x, which is this fraction, minus 200, which is this thing, is 0. Then you can again use the ABC formula as well to solve it. And then this is your x. You could do it that way. That would be way too complicated. You can better just try out the different solutions and see which one gives you a 0. Okay. One important thing to remark is that what I told you about how the IRR and the R tells you something about the NPV. I said if the R was smaller than the IRR, that's what I said, then the NPV would be positive, right? But that was because in moment 0 you had minus 100. Well, 1 second. That was because at moment 0 you had minus 100, and then in moment 1 you had a positive cash flow. Then the IRR was 10%, and then I said, if the discount rate is smaller than that, then the NPV would be positive. But that's just because this was the formula. That was simply because the first cash flow was negative. If I would switch it around and I would make it like this, positive 100 and then a negative 110, then the IRR would be minus 10% here. Is that correct? I guess. I actually don't know. We can see. So 100 minus 110 divided by 1 plus R. Is this correct? Or is it still 10%? I think it's still 10%, right? Do you guys agree? Yeah, I think it's 10%. It's basically like you're borrowing a 100 euro and you have to pay back 110. So basically you use an interest rate of 10%. So the IR is 10%. Here it would be switched. So you will see that now if I use a number, an R smaller than 10%, here you will have that the NPV becomes negative. If I now use an R smaller than the 10%, you can try it out in your calculator. You will see that the NPV is negative. So it's really important to keep track on which cash flow comes first. Most of the time, it's this situation where you first pay a negative cash flow and then a positive cash flow. But in theory, it could be switched. And that's what I want to tell you with this slide. So if you look at your work group examples that you get each week, I think in week 2, I'm not sure, then you had an exercise where they switched it around. Maybe do you guys know what I'm talking about which exercise? There you first had a positive cash flow and then a negative cash flow. Then it basically works a bit differently. Okay. So let's do some action questions. And then I think we are almost done. So it's almost 6. Who likes to help me? Amy, would you like to help me with this situation? So I always propose to first make the table to translate the story into a table. So how would you explain it?
So negative 100,000.
At which moment?
0. Year
Yes.
0.
Very good.
Yeah. Year 7, positive 500,000.
Yes. And the cost of capital is 20%, right? So how do I start now? This is correct. So you now invest 100,000 and then 7 years later you get 500,000.
So
how do I find
a 0 equals to minus 100,000 plus 500,000 divided by 1 plus 0.2 to the power of 7.
1 plus IRR, right?
Oh, yeah.
Because we don't want to, yeah, if I would ask you for the net present value, you were right. But I now want to find the IRR. Yes. Okay, now I need to, and with the power of what did you say? With the power of
7.
7. Very good. Okay, how would I do it?
500,000 divided by 100,000 is 5.
Mhm.
And then move to the power of 7 to the other side, subtract 1 from that, and we get
Mhm.
85%.
Yes. So I agree that this is obviously 5. I just want you to notice the structure so that you can do it faster in the future. Okay. What did you get to say?
25.85.
Like this, right?
Yep.
Okay, let's have a look. It's indeed answer D. Very good. So basically, you made an investment, 100,000, and it's like you would get an interest of 25.85% each year, and then 7 years later you have 500,000, right? That's basically what happens. Was this a good investment given that the interest rate is 20%?
Yeah.
Yes, right.
Yeah.
It was a good investment because if you
Yeah.
would put your money in the bank, you would only get 20% interest, and now you basically got 25.8.5% interest. And that means that since it's a good investment, your NPV is positive here. Your NPV would be positive here. Okay, so it's answer D. Very good. Then here, I will just let you guys do this on your own. And then you can send me the answer in the Zoom chat. See the first answers coming in. Very good, OM. Very good, Amy. What did you guys, by the way, have for the NPV of Y? Did you get 243.43
Yeah.
and 464.01?
Mm-hmm.
Okay. And we said that you actually should now choose for which project based on the NPV. You should choose for X or for Y. You should choose for X. X is the best option, right? Because that has the highest NPV. However, if you would go for the project with the highest IRR, you would choose for Y, which would be the wrong choice. It's not about the IRR. You should look at the NPV. But if you would do it, then you would make a loss of how much? If you take the difference of those.
220.58.
58?
Yeah.
220.58, you say.
Mm-hmm.
Okay. Did you
Which is
also, did the rest also have that? Sorry?
And it's rounded to 221.
Okay. That's correct. So you say it's option C, right? And that's correct. Okay. I think this one was relatively easy, right? Okay. Are there any questions about this exercise? No? Okay. Then my question to you guys is, would you also like me to discuss the effective annual rate? Or do you say, well, it was enough for today, thank you? What do you guys think? Do you still have the energy or are you guys tired?
I think you can continue. Right?
Sorry?
I think you can just explain it, I guess.
Sorry, I couldn't hear you, Philip.
I think you can just explain the last part which you just wanted to explain.
You would like me to explain the effective annual rate? How about the
Yeah.
rest? What does the rest think?
Yeah, same.
Okay,
Yeah,
then
yeah,
I will
sure.
also explain the effective annual rate. Nice. I just want to see if you guys would like it. Great. Okay. So let's do that. It's a small topic. It's actually quite easy. So the short answer is remember this formula and you're fine. But I'm not here to tell you learn this formula and then you're fine. I want you to understand what this formula represents. So that's what I'm going to show you on the whiteboard. Okay. So to explain it, it goes like this. You have an annual percentage rate of 100%, which is really high, right? You basically double your money each year. But here's the interesting thing. You have the N, and that is how many times the interest gets paid out in a year. So for example, if we start with €1 at t is 0, then you get 50% semi-annually. So let me do that with a different color. So you get 50% in your first half a year and 50% in your second half a year, because this 100% gets paid out twice a year. So you do APR divided by 2, which is 50, and you get that twice. And the interesting thing is that it can compound more. So you started with €1, and after half a year, you have 50% interest. So that will give you 1.50. Okay, that's what you expect. But here's the interesting part. You get another 50% interest on this €1.50. So how much do we get here? If you do now 1.5 times 1.5, maybe I can also use the €100, then you maybe see it better. I start with €100, for example. Then now I have 150. And then how much you have after that year? So what will be the number here? If I get on this 150, 50% interest, do you guys have an idea?
225.
225. That's interesting, because according to the APR, I should go from 100 to 200. But because the N is 2 and not 1, I effectively got 125% instead of €100. Do you see that? So it's beneficial if your N is bigger than 1. Then you get a bit more interest because it can compound more. So do you guys understand this first example? Let's do it a bit differently. Let's say I get the APR of 100%. But now the interest is paid out quarterly. So it gets paid out 4 times a year. So same sketch. I have to make it a bit longer, else it will not fit. Do you guys agree that if the interest is paid out 4 times a year, I get 25% here for the first quarter, 25% for the second quarter, 25% on the third quarter, and 25% on the fourth quarter. So for example, here after the first quarter, I end up with 125, right? With how much do I end up after the third year? After half a year, sorry. Does anyone have an idea?
156.25.
Yes, very good, Amy. And then at this moment?
195.31.
Yes. And then at the end of the period, by how much do I end up?
244.14.
244.44, you say?
14.
A 14. What is here the effective annual rate? I started with €100, but I end up with 244.14. And here the effective annual rate was?
$144.14%.
Very good. And that's what it is. So the higher, so you now need to see what the APR is. That's basically the interest rate they tell you. But if the N is bigger than 1, your effective annual rate will actually be a bit higher than the APR. And that's because you have more time to compound. It will compound more in a year. And therefore you end up with in reality, a bit higher interest rate. You see that? Okay. So let's have a look at the formula. If we have a look at the, is it by the way clear what the APR, the N, and the ER, the effective annual rate is? That's clear for everyone. APR and effective annual rate. Or do I need to give another example? If we look at this formula, now we can see that this will give us the same result as we got when we did it in the intuitive way. Because in the future, you will not, if you, for example, have 365 days, you don't want to make this whole sketch, right? That would take way too long. So you need a nice formula, and that's this formula here. And it's on your formula sheet, so you don't need to remember it. So let's fill it in. So the formula, I will also write it down here. Effective annual rate is 1 plus APR divided by N with the power of N minus 1. That's the formula here. You see it? Okay. Could you give it a try? See if you also get 125. So you do 1 plus 100%. And remember, 10% is the same as 0.10. 5% is the same as 0.05. So 100% is the same as 1, right? And if you fill this into your calculator, do you get 1.25 if you fill this into your calculator? Do you get 1.25?
Yeah.
Yes, which is 125%. If you fill this in, 1 plus 1 over 4 with the power of 4 minus 1, do you get 1.4414? Yes, right. And that's how the formula works. Okay, so now it should be clear what the APR is, what I mean with N, the amount of times the interest get paid, and with the effective annual rate, and why the effective annual rate is higher than the APR, because it can compound more. Okay. So I have 2 action questions, and then we're done. So Eva, would you like to help me again?
Okay.
So what was the formula again for the effective annual rate?
Well, 1 plus the APR, so 0.1, divided by K.
Yeah, K, sorry, a K or N, doesn't matter.
To the power of K minus 1.
Yes. Okay. What is the APR here?
0.1.
Yes, 0.1. Not 10, but 0.1. And then the K is, if it's compounded
4.
quarterly, 4. And what do we get?
Uh, 10.4%.
Yeah. What do you get?
See.
Hold on.
10.38%?
Yeah.
Yes. Let's see if that's correct. Yes, that's correct. Very good. Thank you, Eva. So it's actually quite easy, but I want you to really understand the formula, right? What it tells you. OM, would you like to do the last one? By the way, assume that there are 365 days in a year. So what do you fill in for the APR?
0.199.
199. And for the K, if there are 365 days in a year?
Yeah, 365 times.
What do you get?
Got 0.220.
And if you multiply that by 100,
C.
how much percent? C, 22.0%. Let's see if that's correct. Perfect, that's correct. Very good, guys. And that's it. So thank you very much for today. Are there any questions? No questions? All right. Then have a nice day. Enjoy the weather. And maybe I see you soon.
Thank you.
Bye, guys.
Thank you. Goodbye.
You're welcome. Bye.